Hello viewers, welcome to Quick Coder. My name is Tulsi. Today's topic is finding kth smallest element in an array using quick select. So let's get started. Okay, today's topic is finding kth smallest element in an array. Okay, so for suppose the given array is 2, 8, 1, 3, 7, 6, 4, 5. So you want the let's say third smallest element in this array. So what students usually do is they will first sort the array. So after sorting we will get this array and they will return array of k minus 1 as we have 0 based indexing. So if we want third element, we want to get the k minus 1, that is the element at the second position. So what we usually do this, but the interviewer asks for some like some optimizer solution for this. So we have many solutions, but now I'm discussing one of the optimizer solution using quick select. Okay, and I request you students, if you have any other optimizer solution, then I request you people to share in the comment section. Okay, so let's get started. Okay, so let's get started using quick select method. Okay, what we usually do is it is very similar to quick sort. Okay, what we do is, so let's say this is the original array. So let's remove this. Okay, so this is the original array. What we usually do is we will find a pivot point. So let's say the last element is the pivot point. Then we will arrange these elements according to this pivot point. So like partition and array. So if you do not watch that partition and array using pivot point, then you can go through that video. I already uploaded that. So then come back to this video. So what we usually, what will be done in partition and array is, so let's say this is the pivot point like 5. So the elements which are less than or equal to 5 will be at its left side and the elements which are large will be at the right side. So that is nothing but partitioning an array using the pivot point. So let's try this partitioning an array. What we usually do, we have some algorithm, but without using that algorithm also, without tracing the whole code again. So let's say this is the pivot point. What we can do is, so this is the smallest element of 5. So I will place this here. Okay, so I will place this here, and 8 is somewhat large. So let's mark it. 1 is smaller, 3 is smaller, 7 is larger, 6 is larger, 4 is smaller, and then write 5. Then again the marked elements write as. So if you trace this code with that partition function also, then you will get the same array. Now what we will do is, so we will return the index of this pivot element. So after partitioning an array, okay, let me write indexes also 0, 1, 2, 3, 4, 5, 6, 7. Okay, now my pivot point index is at 4. But what I want the kth smallest element. Kth smallest element is nothing but the element at the second index of the sorting an array. So we can say as the elements which are lesser than 5 are at here and it is at the fourth index, we can say that the second element will be in this position only. Something like binary such like that. Okay, so this position, then we will we will not compare this position and we will take this part. We will take this part. And now when we consider this part, what is the pivot point here? 4. So my pivot point will be 4. Now what will happen is same. 2 is less than 4. So I will write here 1 is less than 4. I will write here 3 is less than 4 and 4 is less than 4 as it is. And my index is also like 0, 1, 2, 3. Now I will check this one. So my pivot is at third index. Now I want the second element. Means 3 is greater than 2 means it will be in this position only again. Now again I will take my pivot as like this. Okay. Now I will take my pivot point as 3. Now again what I will do is as 2 is less than 3 I will write as it is, 1 is less than 3 and again 3 as it is. Now 0, 1, 2. Now my pivot point is at second index. Okay, and now I want the element at, I want the element at the second position. So my pivot point index is also 2. So 2 is equal to 2. That means 3 is the right answer. Is it right or wrong? Because if we sort this array 1, 2, 3, 4, 5, 6, 7, 8, we will get this. What is the third smallest element? 3. So we got 3. Means we always take some pivot point and array and partition the array using that pivot point. Then we will check the index position of that pivot point. If it is greater than the k minus 1. Okay, if it is greater than k minus 1. So what we usually done here, okay, we partition the array based on the pivot point 5. My pivot point is at 4. My k minus 1, 2 is less than 4, no, means I will check this position. And again, I will take the pivot point as last one. And now again, I will compare the index position of that pivot point 3, as 3 is greater than k minus 1. So it will be in this part only. And again, I took this part and I again took the, the last element 3. And now I partition the array. Now if I check the index position of the 3, the index 2 is equal to 2, k minus 1. So this is the answer. Like this, we can check the kth smallest element using the simple quick select algorithm. So what we are doing, we are always reducing the, we are always reducing here. So here this part is reduced. So like that we can reduce the. So as these elements are already less than the pivot point, here it is not shown clearly. But if we take some other example, it will be very clear. Okay. So okay, let's get started to coding. Okay, so let's start coding and see here. This is the function quick select function. Quick select function we have to implement. Okay, here there is k, no. Initially I took k as k minus 1. So wait, I will show that. See here. So initially I took k and I passed k minus 1. So no need to again check with k minus 1 again. So I already passed k minus 1. So it is easy. Now, what will happen here? So first of all, what we should do, we should find out the, first of all, we should take the pivot point. So what I will do is, let's take, okay, so let's call the partition function. Okay, here the partition function is already implemented. So if you are not clear about this function, I recommend you to go to partitioning an array. I already uploaded that video. Okay, partition, and I'm passing array and low and high. Then what it is returning? It is returning the index position of the particular pivot point. So I will store that index position in pi. Okay. Again, now what I will do is I will check. If my pi is greater than k, then I should check only some part, like return quick select of array. Low will be low and high will be up to pi minus 1. And again I will pass k. Or else if my pi is less than k, then I will return quick select of array low, pi plus 1 to I and k. Otherwise, simply return array of pi. So that's it. So I will trace the code, don't worry. So now let's run the code. Something like compilation error. What happens? array low sorry here sorry here my in partition function I should have also pivot no. So what I will do is let's take int, but for not like this we can also remove this one and we can add something here like int pivot is equal to array of type. Okay, so let's run now. Okay, accepted. Let's submit. Okay, correct. So don't worry, now we can analyze the code. Okay. Okay, so let's get started. So in quick select method, I'm passing array. Low is 0 as the starting index and high is the ending index 7 and k is 6. So I want to find the sixth smallest element. So what is the sixth smallest element here? So let's first sort the array. So this is the sixth smallest element. So let's what is the next step here? We are passing this array low and high. So what we are doing is to partition array, to partition function, we are passing array 0 and 7. So what this partition function is returning, it is returning the pivot point position. So what is my pivot point position here? So this is my pivot point now. My pivot point position is, see how is the pivot point, what how partition occurs. 2 is less than 5. Okay, 2, 8. Okay, let's mark it. 1 is less than 5. 3 is less than 5. 7 is not less than 6 is not less than 5. Okay, 4 is less than 5. Now I will write 5 and I will write as this 8, 7, 6. Okay. Now what will be the indexes? 0, 1, 2, 3, 4, 5, 6, 7. So index of the pivot point is 4. So it will return 4. Okay, in my pi it will have 4 and is 4 is greater than k. So we have to find the sixth smallest element, but as it follows the zero based indexing, I want to search for the 6 minus 1, that is fifth one here. Okay, is my 4 is greater than 5? No. Here we can check. Here my 4 is less than 5. Yes. So we have to call the quick select of. Again quick select of, we are passing array and pi plus 1. Pi plus means 4 plus 1, 5 and high means 7 and I am passing again k, that is 5. Okay, here is not k is 6, here k is 5. Internally the k is 6. We have to find the sixth smallest element only, but as it is the, zero based indexing, I am passing k as 5. Okay, now again it is calling quick select of array 5, 7, 5. Low as 5 and high as 7. Now this array will contain up to, means it will check up to 8, 7, 6. Means whole array is passed like 2, 1, 3, 4, 5, 8, 7, 6. Whole array is passed, but it will check up to 5 to 7. Means as indexing is like this, 5 to 7 means it will check up to 8, 7, 6. Now again, what is the, again it will call the partition function. Okay, again it will call the partition function. In partition function, okay, again in partition function, I am passing the array and low. Low means 5 and high means 7. Now what will happen in partition? Again, it will take the, okay, now it will take up to these elements and it will consider the 6 as pivot element. 6 as pivot element. If 6 as pivot element, is 6 less than 8? No, mark it. Is 6 less than 7? No, mark it. Now 6 will be printed and 8, 7 will be there. 8, 7 will be there. Okay. So we have remaining elements also like 2, 1, 3, 4, 5, but these are the main important things. Now what is the index position of 6? Means we are our pivot point is 6 only. No, what is the index position? It's 0, 1, 2, 3, 4, 5, 6, 7. Okay, now index position, I mean my 6 is at 5. Now it will return, 5. Now again it will check, is my pi is greater than k? Means is my 5 is greater than 5? No. Again it will check, is my 5 is less than 5? No. Else return array of pi. What is the array of pi? Array of 5 is 6. So it will return 6. So 6 is the right answer. So that's it. That's it. What we are doing, we always checking if my pivot element is my pivot index is greater than k, then we are checking the left part. Otherwise, we are checking the right part. Again, it goes on like that. So this is very simple algorithm and very fancy algorithm, and this is also very, I mean, repeated question how to find the k smallest element. Even I usually do first sorting, then I'm printing k minus 1 element. So not like that. We should do it differently. Okay, so I hope you have understood this one. Thank you friends. Thank you for watching this video. The coming up video is count sort in Java. Okay, so let's wait for that and subscribe to my channel Quick Coder to get notified for the further videos. Thank you. Thank you for watching.